So this one we actually did before. And you could always, many of these you could break up multiple different ways. So either you want to do it, one way is to do it, the first way to do it is to break it up into a number that is a square, because then you can square root it. So in this case, 25 times 2. Because then you can break that up, you can do a part of it, and you can't do the other part. Bam! Or, the second method, take 50, maybe go to 5 times 10, and then go to 5 times 5 times 2. Any group of 2 comes out as 1, so you get the same answer. You pick which way is better. I'm not going to force you to do one way or the other. This way just is, it's not as easy to make simple mistakes, but this one is a little bit simpler in the middle. So it's, give me that. This one might be one that some people had to do a couple steps. So how do you guys break up 72? All right, so 9 times 8. All right.
36.
She did it again. Just like if I ask you to reduce a fraction, do you sometimes have to do it more than once because you didn't think about a high enough number to divide? Right? Of course. Same thing's going to happen here. So I agree with you. Square root of 9 is 3. Square root of 8, I don't know. But what's 8 got in it? Frickin' 4. Square root of 4 is times 3. And so what you going to do was 72 is 36 times 2. Square root of 36 is 6. Square root of 2 is, I don't know. It doesn't matter. If you don't see it, who cares? You just do one more step. Just like when you're reducing fractions. No big deal. You guys, all right? Okay.
So we gotta come on here until we got one more.
So you,
So I stopped at 3, 8, so I used to.
oh yeah, so the 8's got another square in it. So you got to keep going all the way. It's sort of like if I said, what you got, Jeff? If I said reduce 12 over 24, and you said it was 6 over 12, you're right, but keep going. Yeah, exactly. Same exact idea here. So I often call this reducing the radical because it is so much like reducing a fraction. You got to reduce it all the way. All right, what about this dude? There's really only one way it'll work. Yeah, 4 times 30. Because 30 don't have no squares in it. So then you get 2 rad 30. So one reason why I don't like this method is because something just comes out. Whereas this, why is there a 5 there? Because the square root of 25 is 5. That's why it just is. That's why I put it there. Maybe. What about this guy? All right, let's do this one the second method. Why not? So if I think 8 times 10, keep going. 8 is 2 times 2 times 2. 10 is 2 times 5. I like it. And so I circle my groups of 2. So I got 2 factors of 2, which of course is 4. Now the other way to do it is to say this is 16 times 5. Square root of 16 is 4. Square root of 5 is I don't know. Or you could do 4 times 20, but then 20 has another 4 in it, so you got to do a couple steps, and then eventually get down there. Okay, maybe. So this is exactly like reducing fractions. It's just we're using factors to do this, really, more directly. What about number 5? Yeah, there's only 11 times 3, so I don't have 2 of anything. There's no squares in it, so it's done. Simplified.
You don't say prime.
Yeah, not prime.
No prime.
33 is prime, but it's like if I said what's the square root of 6, it's done. The 6 isn't prime.
Mm-hmm.
All right, so don't say prime. That's not what matters. And then the best one on there, subcorner of 29. What's 7 plus 2 plus 9? 7 plus 2 plus 9? 18. So 9 goes into it, right? 9 times 81. So this is 9 times 9 times 9. So it's cube rootable. Guess, see that? The cube root wants groups of 3s. And you're all like, I don't give a shit, Jeff. The problem was the square root. I'm like, all right, now watch. This is so cool. Just, you guys did this. Somebody did this beautifully like this. I love that shit. Look at that. It says 3 times 3 times 3, right? I want to show you something kind of funky. Take 9 times 9 times 9. 9 times 3 times 3. Is that cool? So 27 times 27. There. The square root of 20 is 27. Because it takes 2 27s to make it. 64. We've seen 64 do this before, right? Isn't 64 a square? And it's a cube. 64 is 4 times 4 times 4. If I break the 4 up in the middle, I get 8 times 8. 64 is cube rootable and square rootable. Sorry if you didn't care. I just couldn't stop myself. I think that's so
So
neat.
what's the answer?
27. Get there eventually. So there's multiple ways to get to the answer. As long as you show me what you're doing.
Mm.
Let students write down what buttons they push in the calculator for me. Let's see what you move. All right. So I want, how are we doing? How do you feel about that? You still need to get comfortable with it, but I really want you to see how this is so similar to stuff we've done before. You do have to know 4, 9, 16, 20. You got to have a decent grasp of those. Might as well just have them sitting next to you and get them in your head when you're doing these problems. Like it. So now watch. A really, really good question in general that I'm surprised nobody's asked me about yet is why the shit do I need to do this? Besides, I appreciate how much you guys have held back on it. So my first answer is always, well, we passed the damn class. So. But here's, as always, my reasoning is never accepted well because it has to do with doing more complicated math problems. But the more complicated the math gets, the closer to real life it gets. So now watch. Let me see what you guys, all right, let me start with something really silly. What's 2x plus x? Holy shit, what? Did you say 3x or 4x? Okay. Sorry, I thought you said 4 as well. Oh my god. What's 2y plus y? That's crazy. So what's 2 rad 3 plus rad 3? 3 rad 3, I love it. Because what do I do when I'm adding coefficients? I'm collecting how many rad 3s, how many y's, how many x's. Well, I got 3 x's, 3 y's, and I got 3 freaking rad 3s.
Like toes.
So, what is the square root of 3? What is it? Tell me exactly what it is. Do you know? I don't know is a good answer.
I don't know.
Good. So it's an unknown. So I'm just collecting. I got 2 things I don't know, plus another one. It's 3 freaking things I don't know. That's really the idea for all of those, isn't it? But what's a little different is this isn't really a variable. It's just a number I don't know. So I am able to do a little more with radicals. If I have something that's not like here, what's 2x plus y?
2x plus
2x plus y. You answered your own question, Jeff. Way to go. Oh, look at me. So watch this. I don't know why I want red all of a sudden. So what about this? Square root of, what you got, buddy? There you go. Yeah, look at that shit. All right. At least 4 people in here are going to say this. That answer is square root of 26 on some thing, some test. Maybe we'll find out. That is so not right. That isn't right. You can break them down, right? So here's the trick. I can't do x plus y because I can't do shit with x or y. But this, I can do something with each of them. What does 8 have in it? Yeah. What does 18 got in it? See how they both have that base? So this is 2 rad 2s plus 3 rad 2s is Rad freaking rad 2s. Should be. Since they are numbers, they're like unknowns, but they are numbers, so I should be able to maybe do more with them than if they were really just letters. Those are total unknowns. Maybe. So this ability to simplify radicals does allow us to get more things that it can combine. Which seems to be math people's goal in life, is just to combine everything. Oh yeah, no, I didn't bring it. So here, you guys try this one. Let's see if Jeff can make one that works. That would be neat, wouldn't it? Sure.
You go down some?
I got that.
Yeah.
Again, you gotta really fight yourself to not put square root of 15 in, right? Good. Somebody will do that.
I was like, where'd you get 15?
Do you see where I got?
Yeah, no.
Yeah.
Yes, I thought that.
Because adding, subtracting requires exactly like terms. So these are obviously not exactly like terms. Hopefully it's obvious. So what can you do with rad 27? 9 times 3, so I get 3 rad 3. So then I get 2 rad 3. 1 rad 3. Oh, good. Alright, sweet. Alright, so watch this. What's going to happen if I do this? We'll try it and see, Jeff. Gather, I didn't mean that, sorry. Let's see, what do I do? Sure. Did I just go crazy? I did. Excuse me, man. Will that work? That'll work. No, it won't work. I'm silly. Let me try one more time. You can do it, Jeff. I don't know anymore. I've lost faith in you. Just do that one. That's fine. We did it already, but it's okay. So the big change here, hopefully you guys realize I don't think I'm crazy. I agree with myself on that. So the big change here is that they already have coefficients. What is the operation when we bring a number out? What does it say? 3 times. Right. And kind of what's already out front, what's understood to be here. So whatever we bring out, we are multiplying by what's already out there. So if there's a number out front already, whatever kind of is doable by this root multiplies by what's out there already. Because it is all multiplication. So what is this? 4 times, how can you break up 75? 25 and 3, because 3/4 is 75 cents. Rad 25 is 5. And 4 times 5 is 20. I lost you on the course there. Plus 2, 12 we did earlier. 4 times 3. So that's going to be 2 times 2 times rad 3. So plus 4 rad 3. And then finally, 24 rad 3. Kick ass. Chipoo. Convert mass. So that's a natural, immediate thing you can do with that skill of simplifying a radical. Because then I can simplify more complicated problems. Okay, okay. So last thing, don't forget, I got the practice final. I was gonna, don't forget to get that. There's a practice final. When's the final, guys?
It's on Tuesday.
Yeah, dude, a week from today. Holy shit.
Great.
I already told you, like, next Monday,
Not going to class.
yeah, you can just do whatever you want to get ready for finals. We're gonna have a review this Thursday for the final. So I have the answer key for the practice final. You guys, what's up? So our normal tests are how long? Like an hour and 20 minutes roughly, right? But I just come and do the shit. Stop when you say stop. And the final exam gets how much time?
2 hours.
Yeah, so I can make a test. That's,
5 questions.
5 questions.
you don't want that.
No, we don't. 9 questions. We want-
Multiple choice you want to make? You don't want me to make multiple choice. I would kill you.
Yeah, I like 9 questions, one per chapter. And
With
you're-
A through F in each? I like it.
And you're
Okay.
first.
Got it.
8 through
9, 8, 1 A through F, 2 A through F. I got you. You never know till I get there, so. I was gonna do one more thing. Oh yeah, that's right. So real quick. Last thing, I swear. Did I already say that once?
No.
Good. Oh yeah, very good. Okay. What's the operation between those two? Multiplication. So I'm not trying to simplify and combine it, it's multiplication. Are they both the same root?
Same root, yeah.
Same root, yes. So I'm allowed to go ahead and combine them, yes. Right? That's what we just talked about earlier. So what do I get? Square root of 60. You can break that down. Real quick, doesn't 10 have a factor of 2? Doesn't 6 have a factor of 2? So now don't you have 2 factors of 2? Because you put them together? So you can kind of be smart about it and realize ahead of time that, you know, you're going to get 4 times 15. You see that? Or you can just deal with the 60 when it comes up. So you get 2 rad 15. Is that easy? So there will be problems where you have to combine them and then take a look and see, can I reduce it now? Just like fractions. Oh, I think that's enough. I think we're all feeling the same way at the moment. I'm so ready for the semester to be over, but not because I hate you. I love this. I'm gonna miss this class a lot. I really. But the semester needs to go away. That's right, Dean.
I can make every semester go